Well, first of all, I mean, I think that if you were to tell scientists, 50 years ago that in 50 years you're going to have a device that is that you can hold in your hand that has the capacity of our smartphone technology, I think that the majority of scientists today would say, "Oh no, that's impossible." That in 50 years, I mean, they would find that impossible. I mean, the ability to surf the cloud, the ability to have video conferences with people around the world. I mean, it's, so if you look at the engineering of those devices, it's extraordinary. But nature is just, if not more extraordinary than what we as human beings can come up with in terms of, its capacity for things. And so what I think is that we're really thinking about the brain in the wrong way. I mean, we're thinking of it as being sort of the container of information, and I think it's the navigator of information. In other words, that information is not stored in the synapses. I mean, one of the theories about memory and information storage is that it's in the brain and it's held in the synaptic connections and whatnot. But that doesn't make sense to think of it that way for many reasons. And one of them is that if you look at some of these people who have extraordinary memories, like Kim Peek, who is the person that Rain Man is modeled after. I mean, he had something like 11,000 books memorized word for word by the time that he died in his 50s, and he could recite them forwards and backwards. And that was just a fraction of the information that he knew. I mean, he could also give you directions how to get from any, point A to point B anywhere, and within the United States and maybe even, outside of the United States. And so, people that, could tell you the whole phone book, I mean, so, just that capacity for information, and without them even having to work at remembering it. And so you look at Kim Peek's brain and you would think, oh, okay, so if information is all stored in these interconnections, in the wiring of the brain, then you would expect him to have a highly, interconnected brain, maybe even have more, neurons and synaptic connections than the rest of us. Well, it turns out that he actually didn't have autism. It turns out that he had congenital hydrocephalus, which is when you have a problem with buildup of the cerebrospinal fluid in the brain. And what it does is it pushes the brain against the skull, and the head enlarges, because when you're an infant, that the fontanelles haven't closed yet, so the cranial bones have the capacity to expand. And so he had this huge head that he could barely hold up, and a huge cavity in the middle of it. He was missing the corpus callosum, which is the major band of fibers connecting the left and the right hemisphere. So he had actually a very disconnected brain compared to others, and yet he had an extraordinary memory. So I think that when you actually look at these cases, it really changes that paradigm in neuroscience, and you have to really start looking elsewhere and start looking at other ways in which this organ that's in our skulls can be navigating information. And what I propose is that information may be stored in space-time itself.
So do you have any inkling of an idea how that would work, how that interfaces with our biological, mechanism, essentially our body?
Well, what I think is that first of all, once again, going back to the technology that's in a smartphone. Okay, so we have information that's stored in the cloud. Okay, and so I think that if you think of it as being, if you think of space-time as being somewhat like the cloud, in the sense that we live in a sea of ionized particles. I mean, we live in a sea of energy, and we have these brains that if you look at the components of the brain, if you go beyond just looking at the synapses where neurotransmitters are, go across the synaptic cleft, and you look at what's inside the neuron besides that, and you see that we have these microtubules which function like superconductors. So each neuron has within it these microtubules that the speed of conduction from one end to the next is so fast that it really qualifies for being a superconductor, because the resistance of the entire microtubule is actually less than the resistance of its components. So when you have something that defies our usual thinking of physics. If you have a wire, the longer the wire, the more resistance there is.
Yeah.
But these microtubules are made up of these magnetic dipoles, and they're being studied by scientists because of these special properties that they have, and our neurons are full of them. I mean, and they're not just providing support to the cell. We don't need that much structural support. They're serving some other function. Then, in addition to the microtubules, we have neuromelanin. And neuromelanin has properties of semiconductors. And so, and what I mean by that is that you can have light hit it, and it'll send a different signal. It can change. It can respond to vibration. It can respond to, as in the form of sound. They can respond to light. They can respond to electrical signals. So you've got the gray matter of the brain. The reason why it's called the gray matter is because it's so rich in neuromelanin. And we also know that our bodies are full of biophotons, that biophotons are an essential part of biology. That's a finding that's come out during the course of my career, that we emit biophotons, but at a rate that is below the detection of the naked eye for most people. So I think that if you start thinking of us less as just chemical, beings of flesh, and you start to realize that just like our devices, that we are really, electromagnetic, biophotonic, and beings, and that the brain is like, one of the most sophisticated electromagnetic biophotonic devices imaginable. We're just starting to explore some of these features of it. I think then it opens up a whole different way of thinking about things, rather than just, how could you explain it just by the simple connection? I mean, that's like trying to understand, how a smartphone works. If all you did was just examine, just the anatomy of the components of the circuitry, you wouldn't, unless you get down to looking at the displacement of electrons and all of the other, factors that you see in, semiconductors. Unless you start looking at it from that standpoint, you would never understand how it works. And I think that we need to start looking at the brain that way.
Mm-hmm. Yeah. So essentially, you're saying that there's a very high probability that we are biological emitters and receivers of some subtle electromagnetic fields, which might be the source of information for people who have access to information that, extrasensory perceptions.
That's correct. That's correct.